Hello everyone, welcome to tutorial 12 for the course. So today we will be covering a notebook which we will be fine tuning one of the latest models from Google, Gemma 3. It is very popular and has come out of various capabilities such as it has 140 languages support. It also has so if you go through this block from Hugging Face, it has different size variants like 1 billion, 4 billion, 12 billion and 27 billion. So context window length, it was previously 8000, but now it is 32K for 1 billion and 128K for the rest. It has multimodality support except for 1 billion, so images and text, and it has multilingual support. 1 billion supports only English, but we have 140 languages support in 4 billion, 12 billion and 27 billion and parameters. And if this is the graph and this is the graph of ELO score and parameter size in billions, Gemma 3 is at par with is very far ahead of Llama 3.1405 billion, which is a 405 billion model, and this is only a 27 billion model. And with it is very far ahead. So this has ELO score around 1250, it has a ELO score of 1340. It is not at the same par with DeepSeek R1, but again DeepSeek R1 is a 671 billion parameter model, where Gemma 3 is only 27 billion parameter model. I encourage everyone to go through the technical report of Gemma 3. So here as you can see, it is the table 1 parameter, the vision encoder. So this is a parameter count, and the vocabulary size is 256K. So for 1 billion there is no vision encoder, but for 4 billion, 12 billion, 27 billion there are vision encoders. Similarly, embedding parameters and non-embedding parameters. Like also if you go down, so each of these LLMs has formatting of the formatting for which the the prompt has to be given to the model, and the prompt which were used while pre-training these LLMs. So this is the case for Gemma, where we have a user turn, start of turn, user, model turn, start of turn, model, and end of turn is given by this the end of turn prefix, sort of end of turn word. And so explicitly add BOS token after tokenization, or use add BOS true option in the tokenizer. So and do not use do not tokenize the text BOS as it is in the vocabulary. And there are some other important aspects of the model that when you go through this technical report, you will be able to understand and code it up a little bit better. So for today's lecture, we will be using another library, Unsloth, which is a very cool library. It is kind of a wrapper on top of Hugging Face transformers, but they have some out of the box options and granular also. So they are very easily fine tuned and train LLMs, and they are a bit faster than Hugging Face transformers, because Daniel Han, the company's who runs the company, is a very cool guy, and you can see. So for Gemma 3, its performance is 1.6x faster with 60% less memory. So he goes into the models, sees where it's lacking, and like if you follow him on Twitter, he posts these model summaries when these large LLMs come in, and he updates these notebooks in the GitHub as soon as the models come out of these big tech companies. So let's and again this notebook is adapted from Unsloth. So yeah, so please feel free to go to their GitHub repo and check it out in more further details. So we have installed. So this is the installation code for installing Unsloth in Google Colab. And so Unsloth, the basic API is fast model, which supports loading nearly any model now. This includes vision and text models, and again it has to be run on GPU backend. So these are different 4-bit quantized models that Unsloth has done on top of this on top of the models that are released by, let's say, Gemma. So Gemma is BNB 4-bit. So this has been quantized to 4-bit with superior accuracy and low memory use, and there are other popular models that Unsloth has done. But today we will be using Unsloth's Gemma 4 billion. So fast model dot from Pretend, the same architecture again from Hugging Face's transformers, but max sequence length is so load in 4-bit is true. So we would be loading the model in 4-bit. So model will be quantized to 4-bit quantization. Load in 8-bit is there, full fine tuning. So are we fine tuning the full model, or we are using only LoRa parameters as we have previously seen. So full fine tuning is set to false. Yeah. So this is the model of Unsloth is being downloaded, model.ceph tensors. We will go ahead and maybe it will download. So we will now add this LoRa adapters. We have seen in one of the tutorials how to add LoRa adapters to Hugging Face transformers, but similarly in a similar way we will add these LoRa adapters using Unsloth also. So model is fast model dot get PEFT model. PEFT model is parameter, as you already know by now, it's parameter efficient fine tuning. So we will pass the model. Do you want to fine tune the vision layers? We have turned it to false. Fine tune the language layers, true. Fine tune the attention modules, yes, and fine tune the MLP modules, the FFNs, we set to true. So model has downloaded. Then we have the rank, the LoRa alpha for scaling, LoRa dropout, bias, and random state is for just seed. Now we will be using Gemma 3. We will now use Gemma 3 to format our conversation style tunes. So as we saw in the technical report how the conversation should look like, it should look like this. So BOS, start of the user, who are you, end of turn, then the model starts and then it is doing like this. The model output is 2 plus 2 equal to 4. This is also end of turn. So this is how the your input should be formatted. So we will use a data set from Hugging Face. It's from M. Leborn. He is a very cool guy, and please follow him on Twitter to check out his works. He does some cool job. So it is basically data set in ShareGPT style. ShareGPT style can also be analogous to the Alpaca format that we saw in one of the tutorials. So it has its own different template, which we will be changing according to Gemma. So the name is FinTom 100K. So the FinTom 100K is basically a subset of Acre.ai, the TOM, refiltered using Hugging Face's FineEdu classifier. So let's see one of the data. So as you can see, it's pretty big, the data. So from human value, now the human asks some questions, then again from GPT it does some value, and so on and so forth. So for we will use this as the chat template for Gemma. Then from Unsloth has its own chat templates API, which we can just import the get chat template with the tokenizer, and the chat template is Gemma. So it's already written, in Unsloth, and you don't have to write it again. You can just call the, so if you want to use the llamas or Mistral or Phi's chat templates, just change it here and accordingly change the tokenizer. It will be done on the fly. So let's download Le Bon's FinTom 100K, and the split that we are using is train. So yeah, it's downloaded. Now we will now use standardized data formats to try converting datasets to the correct format for fine tuning purposes. So we have to change the format for fine tuning into correct formats, not like it was here, but according to which the model can consume. So let's see how dataset 100 looks like. So it's basically a list, basically a dictionary. With conversations, like content is what is modulus operator in programming and how can I calculate the modulus of two given numbers, with role user. So this was given by the user. So now it's content that is given by the assistant. Source is this one and score is this one. Excuse me. So we now apply the chat template of Gemma for this text. Now let's apply the chat template of Gemma. We will just apply tokenizer.apply chat template, and on the texts with this function we call datasets.map. We have seen this previously. We can use a map function to apply a function on the whole dataset. With the help of batching, it is very fast. Now let's see how chat template did. Notice how Gemma adds a BOS. So this is explicitly you have to add a BOS in the beginning, as you have seen, as it was, yeah. So as you can see it here also. So now the dataset looks something like this. So this again the dataset 100. So after applying the chat template of Gemma, it is like this. So it is formatted in the chat template that was used by Gemma during pre-training. Now train the model. So now let's use Hugging Face SFT trainer from the TRL library, as we have seen. So more you can view the docs here for the TRL. Yeah, the supervised fine tuning trainer or the SFT trainer. This is very similar to the normal trainer that we, or the sec to sec trainer that we have in Hugging Face transformers. So similar to Hugging Face transformers, from TRL we import the trainer and the config. The trainer we pass in the model, tokenizer the dataset, the eval dataset can be set up for evaluation at a later stage, and we pass the arguments in an SFT config. The dataset text field is the text that we want to we want to use. Then per device train batch size is 2. Now gradient accumulation steps is 4. So gradient accumulation is basically the number of steps that we would go in a forward pass, after which we will do a gradient update in the model. So normally what we do, we update the gradients one step at a time, or one epoch at a time. But when we are setting, so it's steps, so one step at a time we are doing. So we do a forward pass, then we have the backward pass. So while doing a backward pass we update. That is what we normally do. But gradient accumulation steps is set to 2 here. It means that we would do a two forward steps, and then we would accumulate the gradients and do a backward step after the 2 forward steps. So in this way you can save a lot of memory, and also speed up your process a little bit faster, speed up your fine tuning process a little bit faster. Now we have warm up steps. So number of train epochs is set to 1, where it can, so this is 1 for full 1 epoch can be full fine tuning. Then we have max steps. So max steps says the how many steps that we want to train our model. The learning rate is 2e minus 4. You can reduce this. Also you can learn, also you can put a learning rate scheduler. which so it can be linear, it can be cosine, it can be cosine with warm restarts, it can be polynomial also. So please go through the documentation. Then logging steps, how much do you want to log? So you would log the training after each of the steps. The optimizer, we would use AdamW 8-bit. So this optimizer is basically, so basically when the optimization happens, it happens in floating point 32. But this for this case, since we are using LoRa and we are so we also want the optimization to be done in a parameter efficient way, that we won't be use all the 32 bits for that we use in normal fine tuning. We would just do it with 8 bits or 2 bytes, just to to fasten the training process, the fine tuning process. We have a weight decay. So this linear learning rate scheduler is set to linear, seed, and report to none. You can use when weights and biases or TensorBoard to check your graphs and so on and so forth. So this is tokenizing the whole 100k data sets. The numproc has set to be 2, so it will take around 5 minutes. Let's move on. So we can use Unsloth's train on completion method to only train on assistant outputs and ignore the loss on the user's inputs. This helps in increasing accuracy of fine tuning. So what happens is that when we give a prompt to the model generates the user input as well as the answer that is generated by the model. So that two are concatenated and it is given to the user. But we don't want the model, we don't want the fine tuning to be done on the prompt that is that was given by the user or to the user's input. So basically we want the model to be trained on the assistant outputs only, the model that has been generated, the completions that have been generated by the model. We only want to fine tune our model, and the loss calculation has to be done only on those completions. So yeah, so this will be done. Okay, so this is still left, around 1 minute is still there. Okay, moving on. So train data set, so input IDs, if we decode it, so this has been tokenized, and if we decode it again, this is what it looks like. Now let's print the masked out example. You will see only the answer is present. So when we are doing the input IDs dot labels and replace these tokens, this is only the the answer that is given by the model and not the whole thing. Yeah, so it's done. No, it's still left. Around 1 minute is still left. So here there are some memory stats. So while training your model, you should also do some memory profiling as to see which parts of the model, which linear layers, which attention heads are hogging up your GPU memory, and how can you reduce them. You can out of the box Hugging Face transformers or Unsloth have gradient accumulation, then there's gradient checkpointing. You should also always go for automatic mixed precision training. Even torch, there is a library by the PyTorch team also. I think it's called Torch AMP. Yeah, so automatic mixed precision package. So this for the automatic mixed precision package, what this does is that you can train. So the weights of the models are always saved in 32 bits, but you can do away with some. You can do away with some of the layers that you can fine tune in 16 bits, floating point 16, or even BF16, that is BF16. So what it does, it casts the floating point 32 to floating point 16 and does the gradient updates and so on and so forth. So you should always take care of the memory that you are using. So tokenization has been done. So it is training on responses only. again, so train on responses only is the function that the model will be fine tuned on only the generations by the model and not the whole thing. So after that we do a decode and we remove the answer, that and we present only the answer. Now this is what we are getting. So this is the CUDA properties, this is the max memory reserved, that is the peak GPU usage. This is in bytes, so it is just division of that. So max memory is given by this. So the max memory and the start GPU memory, that is can be done. And again, like Hugging Face transformers, similar to that. So as you can see, it is only printing the responses by the assistant. Now if we run this memory stats, as you can see, the maximum memory is 14.741 and this is already reserved 5.475. this is reserved by PyTorch actually. Now when so this similar to Hugging Face's API, Unsloth also has trainer.train. So this is basically starting. So number of epochs is 1, total steps 30, number of examples is 100k, batch size per device is 2, gradient accumulation is 2, GPUs is 1, so data parallel GPU is also 1, and total batch size is 2 into 2 into 1. So 2 is basically the per device batch size, batch size is 2, gradient accumulation is 2, and data parallel is 1. So total batch size is basically 4. So 2 into 2 into 1. Yeah, so even so let's say we have data parallel GPU is equal to 2, we have 2 GPUs. I think Colab has 2 GPUs, 2 T4s. With this then will be changed to 8, and trainable parameters is this much, but since we are using the LoRa, we will only be training 0.37% only. So this the training of the model is going to take some time. Maybe we can move on. So this is the final memory and time stats, simple stuff. So this time went from training, peak memory is this, peak memory reserved for training is this, and so on and so forth. So when you are after you train the model, as you can see, the training has started, and we are training only for 30 steps. So 2-3 minutes it will take. So when we do inference on it, let's run the model via Unsloth's native inference. So according to Gemma, so when you go through the paper, go through the technical report, the recommended settings for inference are temperature 1, top P is the nucleus sampling, and top K is 64, top P is 0.95 and top K is 64. So again we will use the chat template. So this is the message that we want to pass. Then we are the text that will be given is add generation tokenizer.apply. So this chat template for Gemma will be applied to this input, and we will generate the outputs similar to similar to the Hugging Face transformers model.generate. So temperature is this is again is coming from the paper, and again the tokenizer.batch decode is the output. Also you can use a text streamer that is by the transformers for continuous inference. So you can see the generation token by token instead of waiting the whole time. Yeah, so it will take 1 minute. So again saving and loading fine tuning models. To save the final model as the LoRa adapters, you can either use push to hub for online save and save pre-trained for for local save. Note these only saves the LoRa adapters and not the full model. Again to save to 16-bit or GGUF, you can go and look ahead. Look on the internet, and there are many Hugging Face blogs also and how you can save it in 16 bits and GGUF. model.save pretend Gemma 3, this is for local save, and this is for an online save. So you need to have a Hugging Face account token for this, and so on and so forth. So now if you want to add these LoRa adapters, we just set for inference, set to false to true. We want to load this LoRa adapters. So this LoRa matrix, the low dimensional matrix A and B, we want to merge it to our frozen model W, as we have seen in our LoRa tutorial. So if false, this is the method, the model that we used for training, right? So model name LoRa model, match sequence, and load in 4-bit equals to true. Message is this, token.apply, again this. So again, from transformers we do a text streamer, and this is the output that we would get. So as you can see, the trainer has been done. So this is the memory that we used, because it was only, let's do some inference. So it takes a bit of time to do an inference. So continue the sequence 1 1 2 3 5 8. I think many of you guessed this is the Fibonacci sequence, where the 2 is basically the sum of 1 and 2, 3 is basically the sum of 1 and 2. So sorry, 2 was basically sum of 1 and 1, 3 is basically sum of the previous 2, and 5 is again similarly, so on and so forth. So as you can see, the model generates 12, 13. So 5 and 8 gives us 12, 8 and 13 gives us 21, and so on and so forth. So it has been cut off due to the fact that we added only max tokens equals to 64. So you can increase this maximum number of maximum new tokens to continue the sequence. Similarly, we can, so as you can see, it is continuous inference is happening, and the generation is doing token by token. So the sky is blue. So the question was asked why the sky is blue, and so on and so forth. So saving the model, this will do a local save on my Google Drive. When you will run it, you will run it on your Google Drive, and so on and so forth. Similarly, go ahead and try this when so after you do a save, you try to run this, and you will just be running, you will be using the model that you have used it for training. So today we went through a notebook where we learned to use where we saw that how can we fine tune Gemma 3 using Unsloth, and please go through Unsloth's repo and also the technical paper report for Gemma, so that you can build your models in a better way. And this will be posted in the course website, and thank you.